Now let us move towards the next method, next and last method, cross multiplication method. This is easy and interesting also as compared to previous three. This second method which we studied, substitution method, and the third and this fourth one, actually if we include a graphical method also, then these three methods falls under the category of algebraic method, and this is the last algebraic method. So in cross multiplication, what all steps you have to follow, carefully watch how the things are changing and how you will be keeping the following steps in your mind for the next and the remaining questions which are based on this method. So let us start. In cross multiplication method, as its name, as cross multiplication, as its name, we diagonally means opposite points will be multiplied. That I will explain what does it mean diagonally later when we will take one example or concept of this question. So we diagonally multiply the coefficients of the variables. Variables means x and y, and then some constants are also involved in this. Then we have three equal relations, two in the form of variables, that I explain what are all three relations, and one constant. We get the value of variables. Out of these three relations, that is in the form of x, y and constant, we will get the value of x and y directly by cross multiplying from these relations. So let us start. Let we have the following pair of linear equations in two variables. This is first equation and this is second equation. You have to remember this blue ink written letters. In cross multiplication method, first thing you have to do is take everything to the left hand side. This is very important. Everything you have to take to the left hand side and leave the right hand side as 0. So first thing before proceeding in cross multiplication method that you have to do, if it is already 0 then fine. If it is non-zero, that means constant or negative number, then you have to take everything to the left hand side like this. a1x plus b1y minus c1 is equal to 0, equation number 1, and a2x plus b2y minus c2 is equal to 0, equation number 2. Be careful about this. Just see once more. What is this? This blue ink written letters, what does this statement says? That you have to take everything to the left hand side, then only this law, this rule will be valid for the question, otherwise question will be wrong. So now we have done this first step. Everything we have taken to the left hand side. First is marked as equation number 1, second is marked as equation number 2. So we write all these constants we need. We have this x, y, 2 variable, and this is the constant we were talking about, and these all are coefficients we are putting over here writing. We will use it later. Now these are the three relationships which I am going to write here. This watchfully, carefully. first relation, second relation, and here we will have third relation. So these are the three relations which the question, this particular rectangle was talking about, three equal relations. These three relations are connected with equality sign. So look at here, the first relation we will be writing the first variable, that is x. We will write here x upon. What is upon, that I will tell you later. The second variable is y, so we will take y over here, but don't forget to put minus. First is positive, last is positive, the second one will be negative. You have to put minus sign here. So x upon something, that's something I'll explain, equals to minus y upon something, equals to 1 upon. This, I read this sentence, two in the form of variables. Two relations are in the form of variables, means here we have x, here we have y, and one constant. So here it is constant, 1 upon whatever it is, it will come in the denominator here, here, and here, that all three denominators will be constants. Now this, be very watchful while I am writing this denominators, that is very interesting and tricky also. While writing x upon something, so from here just you cover this particular variables and constants, you just cover, you feel like it is not written here, it is hidden, a1x and a2x. Then what do you have, b1 b2 minus c1 c2. So when you are writing a particular variable, then those coefficients will be neglected. When we are talking about x, so coefficients of x will not be considered in the denominator of this x. So what we are going to write, in the denominator of x, the coefficients of y, that is b1 and b2, and the coefficients of constant, that is minus c1 and minus c2, will be written over here. Just like here b1, then b2, the coefficients of y, and then minus c1, this is minus c1, and then minus c2. So you understood now, when we are talking about x, so we will never take the coefficients of x. So the when we are writing x, then coefficients of y and constant will be taken. Similarly, now when we are talking about y, we will not take b1 and b2. Now we will write the coefficients of x, that is a1, a2, and then constant minus c1 and c2, just like this, a1, then a2, then minus c1, and then minus c2. Clear? Once more I repeat, when we are writing this y, you just imagine y is not there, it is hidden. So what is remaining, a1x, a2x, minus c1, minus c2. So these two coefficients will be written constant, a1, a2, and minus c1, c2. Same method will be applied for this particular one. So one is purely constant, so minus c1, c2 are purely constants. So when we are writing the denominator of 1, we will not consider this minus c1 and c2. So what we are going to write here, a1, a2, and b1, b2 only, just like this, a1, a2, b1, b2. This is the only interesting part, or sometimes you may make mistake here. So for that you need to be very careful. First variable you will be writing positive, that is x, second variable minus time y, and third is constant upon. When you are writing x, you will not be taking the coefficient of x, you will be writing the remaining coefficients, that is b1, b2, and minus c1. You will be writing this coefficients of b1, b2, and minus c1, c2. When you are writing for y, you will not be taking this b1 b2, you will be taking a1 a2 and minus c1 c2, and while as you have constant 1, then you will be not taking this minus c1 and c2, you will be talking about a1 a2 and b1 b2. Now one more important thing, we will be what is this method? Cross multiplication method. Now till moment we were unaware about this cross multiplication. We never did this in this anywhere in these steps. So now that cross multiplication started, we will be multiplying diagonally. Diagonally means this way and then this way, but you just need to be little again careful about this red arrow. When you are multiplying this way downwards, you will be writing positive whatever their signs are there. If suppose these are both are positive, so you will be simply multiplying. But while multiplying from downwards to upward, you will be taking one extra negative sign over here. For example, b1 into c2, then minus times b2 into minus c1. Understood? So this red mark means extra minus you will take. Let us same thing here, this way multiplying, no whatever signs are there, that is simple multiplication. While multiplying this way, extra minus we will be putting there. Same thing here, same way here, just what I was talking about. Let us see, x upon, look at here, minus c2, so b1 minus c2, that is minus b1 c2. Okay, now extra minus because of this upward journey, so that minus and this minus into this because of this red arrow, extra minus, so that become plus, and then b2 c1. Clear? I repeat once more, plus into minus b1 into c2, b1 c2, minus extra minus because of this that you are putting outside, and then that minus into this minus becomes plus. So b2 c1 equals to minus y upon minus plus into minus a1 c2, and this minus into this minus again plus a2 c1 equals to, the last one is, here we don't have extra minus anywhere, so a1 b2, and then because of this red sign, minus one minus only, and then a2 into b1. This is called cross multiplication. Now since these three are equal, so in first case we will take connect this x with this constant, we will take these two equal and then solving for x, and then later we will connect these two, y and 1, and then we will cross multiply and then find the value of, then we will be finding the value of y like this. First we will take this red arrow mark, x upon this thing is equal to 1 upon this thing. We will be making these two equal. So from here we will get x is equal to cross multiplication, so 1 into minus b1 c2 plus b2 c1, that will come to the numerator here. Okay, minus b1 c2 plus b2 c1, and the denominator is this one, 1 upon a1 b2 minus a2 b1. Clear? So from these two we got the value of x, and this is final solution of variable x. Now the next step is taking these two equal, green arrow, y and this one, minus y and this one. So what will happen? Y is equal to minus time minus a1 c2 plus a2 c1 here, and upon denominator same as we have of x, so that is a1 b2 minus a2 b1. So this is all about cross multiplication method. Eventually we got the value of x in terms of purely constant, and in terms of next is value of y also in terms of purely constant. So this is the only process that you need to be little careful over here. Directly we are just taking the coefficients only and then cross multiplying and then making it taking two at a time, and then 2 at a time from the first will give you the value of x, and 2 at a time in the second case will give you the value of y. Unlike first graphical method where you were taking equation and solving it and making graph, and the second is substitution where you were taking the value from first equation of any variable and then putting in next and then solving, and then third elimination method where you were eliminating the any of the variable. Unlike all these three, we are directly putting the equation 1 and equation 2 and then direct we have solutions, the value of x and the value of y. So this is all about cross multiplication method. Let us start exercise 3.5 based on cross multiplication method. So here we start question number first. Which of the following pairs of linear equations has unique solution, no solution, or infinitely many solutions? Means infinite solutions. In case there is a unique solution, find it by using cross multiplication method. So what does it mean? First of all, before proceeding for the solution, you need to check whether the system has unique solutions or no solution or infinitely many solutions. In case there is a unique solution, means if the solutions are unique, you remember that condition a1 upon a2 is not equal to b1 upon b2 is the condition for checking unique solutions. So then we have to find out, in that case, this case unique solutions, we have to find out those solutions by cross multiplication method. So let us proceed. We have two lines, x minus 3y minus 3 is equal to 0 and 3x minus 9y minus 2 is equal to 0. For the solution, here a1 upon a2 is 1 upon 3, this is 1 upon 3, and b1 upon b2, so that is minus 3, this minus 3 upon minus 9, so minus minus cancel, and then 3 1 is 3, 3 3 is 9, so 1 upon 3, and c1 upon c2, that is the last one, minus 3 upon 2. So in that case, this minus and minus cancel, so we have 3 upon 2. So now we have all the three relations. Let us check now. a1 upon a2 is 1 upon 3 and b1 upon b2 is 1 upon 3. So that means a1 upon a2 is equal to b1 upon b2, but it is not equal to 3 upon 2. So c1 upon c2 is not equal to any of these two. So means it's clear from the above result that lines are parallel, hence no solution. So in that case, we need not to do anything because system has no solution. So we were asked just to check it, and we checked and found no solution. So over, this question is over here, this part. Same question number 1, and the part number 4 says x minus 3y minus 7 is equal to 0, first equation, and the second equation is 3x minus 3y minus 15 is equal to 0. Let us go for its solution. Here a1 upon a2 is equal to no coefficient, so means 1, and here we have 3, so 1 upon 3. Next is b1 upon b2, that is this minus 3 upon this minus 3. So minus 3 cancel is equal to 1. Then C1 upon C2, that we need not to check, because here you can see 1 upon 3 is not equal to 1. That means A1 upon A2 is not equal to B1 upon B2. Means we have unique solutions. So we have intersecting lines in case of graph. Therefore, we have unique solutions. Let us find by cross multiplication method. So here x upon, as I told you, this in case of this x, while you will be writing this, taking this variable x, then you will be writing the coefficients of b1 and b2, that is minus 3 and minus 3 over here. And in case of this C1 and C2, you will be writing full as minus 7 and minus 15 over here. Next is equals to minus times y upon, now while you are writing this y, you will be writing the coefficient of this x and this x. So this is 1 and this is 3. So 1 and 3, and then this minus 7 and this minus 15 we have written here. And then in case of constant, which is this last one, 1 upon, so in that case this 1 upon, we have a1 upon a1 and a2, that is 1 3, and b1 b2, that is minus 3 minus 3. Now in this case, what we are going to do here, x upon, so as I told you, when you are multiplying downward this way, cross multiplication, then whatever signs are available, you will be simply multiplying this. While as when you multiply from this bottom to top, then you will put extra minus over here for this upward journey. So here we have 2 minus, and then another minus will come for the upward multiplication. Similarly, this way you will be multiplying, and while you are multiplying this way, you will have extra minus. Same thing here. So while you are multiplying, I explain, you will be multiplying first this way, okay, and then you will be multiplying this way. Similarly, here also you will be multiplying first this way and then this way. Same thing here, and then this last one. So you will have x upon 45. 45 means this minus and this minus plus, and 15 threes are 45. Now extra minus will come while multiplying these two. So in this case, minus 7 into this minus 7, and then extra minus for this upward journey, upward. So that minus 1 minus into minus plus, plus into minus minus, and 3 7s are 21. Next is minus y upon 1 into minus 15, and then extra minus, and this minus of 7 will become plus. So minus 15 and minus into minus plus 21. Let us move towards the last one, which is 1 upon this 1 into minus 3 is minus 3, and then extra minus we are putting for this upward journey, so then that minus is we are putting outside, and then 3 into minus 3, that is minus 9. So minus into minus, this will become plus 9. The next step is we have x upon 24 is 45 and minus 21, 24 minus y, that y, this minus I am putting out downward, 21 minus 15 plus 6. So this minus, actually this minus we are writing here, this minus. So actually this plus y upon this minus 15 plus 21 plus 6, so that minus we have taken to the bottom, equals to 1 upon minus 3 plus 9 is equal to 6. Now as I told you, what did I tell you? You will be taking this and this term, x upon 24 equals this, x upon 24 equals to 1 upon 6. This will give you x upon 24 is equal to 1 upon 6, and then you will take this y upon minus 6 equals to 1 upon 6. This is here. Okay, so 124 equals to 1 upon 6 and y upon minus 6 is equal to 1 upon 6. Then cross multiplication. So this 6, actually this 6, this 4, 24 will cancel, so we will have this thing plus 4, and this 6 will cancel with this 6. So cross multiplication, we will have y is equal to minus 1. So x, we will multiply this 4 to this 1, so this will go here, and this minus 1 will go to here. So x is equal to 4 into 1, 4, and y is equal to minus 1. So x is equal to plus 4 and y is equal to minus 1 is the solution of this system of equation. The next part of this exercise, that is question number 2. Question number 2, part number first says, for which value of a and b does the following pair of linear equations have an infinite number of solutions? Means what? Case the condition is given infinite solutions, so we need to remember what is that condition. That condition is a1 upon a2 and b1 upon b2 equals to c1 upon c2. That condition we will apply because it is already given, infinite solutions are there, and then you have to find out the value of a and b. So we will start with the question that the system of equations is already having infinite solutions. So let us proceed for the solution. Now here a1 upon a2 means this coefficient of x, and then a2 means the coefficient of this x, that is a minus b. So 2 upon a minus b. b1 upon b2 means b1 is 3 and b2 is this a plus b. So b1 upon b2 is equal to 3 upon a plus b. And then c1 upon c2. c1 means this 7 we will take to the left hand side, so that will become negative. That's why we have written here minus 7. And then this 3a plus b minus 2, that is this is also we are taking to the left hand side, then minus we are putting outside. So this is c2 and this is c1. So minus 7 upon minus 3a plus b, 3a plus b minus 2, so equals to minus, this minus cancel with this minus. Now for infinite solutions as asked in the question, we must have a1 upon a2, b1 upon b2 equals to c1 upon c2. These three must be equal. So we will put all these values above in this result. So that is a1 upon a2, that is 2 upon a minus b, it is equal to b1 upon b2 equals to c1 upon c2. So any value we can put first, a1 upon a2, 2 upon a minus b here, this one, and then c1 upon c2 we have taken here, so that is 7 upon this thing, 7 upon 3a plus b minus 2. Let us cross multiply this way. So we will have this as I explain it, we are multiplying this way and this way. So 2 into 3 is 6, 2 into 2b, and then 2 into minus 2 minus 4 equals to 7a minus 7b. Now 6a plus 2b minus 4 and 7a minus 7b. So we are taking all this because 7a is greater value. So we'll take 6a to that side, 2b is also that side, and minus 4. So let us have this equation first, because 7a minus 6a plus a and minus 7b minus 2b, this will also go to that side, minus 7b and minus 2b minus 9b, and equals to minus 4. It is already in the right hand side. So equation number first from these two. Okay, then next is, now we are taking first and second. Here we had taken first and third, so let us take a1 upon a2, that is 2 upon a minus b, and equals to b1 upon b2, which is 3 upon a plus b. Let us cross multiply again this way and this way. So 2a plus 2b is equal to 3a minus 3b. So now everything will be taken again same way. So that is this 2a and 3a minus 2a plus a, and minus 3b minus 2b minus 5b, we have no constant, so equals to 0. Equation number 2. Now we'll solve these two for a and b, and that will be the end of the question, like what we were doing for x and y in the previous exercise. So subtracting 1 and 2. Why? Because the coefficient of a is 1 and the coefficient of this a is also 1, same coefficients with the same sign, plus plus. So we are subtracting 1 and 2. So that is a minus 5b is equal to 0, and a minus 9b is equal to minus 4. So this plus become minus. We are applying elimination method over here, and then this minus become plus, this plus will become, this minus will become plus. So these two cancel, this a and this a cancel. So 9b minus 5b, 4b is equal to plus 4. Then this 4 and this 4 cancel, so b is equal to plus 1. Then putting this value of b into, we get a minus 5 into 1. A minus 5 into 1 over here. This we are putting the value of b is equal to 0, a is equal to plus 5. So we have now, hence a is equal to 5 and b is equal to this 1. Okay, for which the system of this equation have, hence a is equal to 5 and b is equal to 1, for which the system of equations has infinite solutions. So that is the end of this question number 2, part number 1. We move to next question. The question is, for which value of k will the following pair of linear equations have no solutions? Now the condition in the previous question was infinite solutions. Now here the condition is for no solutions. No solutions means a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. So here we have two equations, equation number 1, equation number 2. Let us proceed. Now we will find a1 upon a2. a1 means this 3 and a2 means 2k minus 1. Next is b1 upon b2. So b1 is here, the coefficient of y is 1, so that is 1, and then this b2 is k minus 1, so k minus 1. Next is c1 upon c2, so that directly we can write 1 upon 2k plus 1. So this 3 we got. Now we will move according to the question. For no solutions, a1 upon a2 is equal to b1 upon b2. a1 upon a2 is equal to b1 upon b2 must not be equal to c1 upon c2. So here we will put the values. This 3 upon 2k minus 1, a1 upon a2, b1 upon b2, 1 upon this k minus 1, and c1 upon c2, 1 upon 2k plus 1. So now term by term will take. First two we have taken 3 upon 2k minus 1 and 1 upon k minus 1. So we'll cross multiply this way and we will find the value of k. So 3k minus 3 and 2k minus 1 equals to in the right hand side. So here we have 3k minus 2k in the left hand side, so k, and minus 3 will go to the right hand side, so plus 3 minus 1 is equal to plus 2. So we got the value of k equals to 2. Okay, question number 4. For the pair of linear equations in the following problems and find their solutions. First of all, that means we have some English statements. Then those English statements we are asked to convert them into mathematical statements and then find their solutions if they exist. If they exist, then only we have to find by an algebraic method. By an algebraic method means we can apply here any of those 3 methods except graphical method. That means substitution method, elimination method, or cross multiplication method. We can apply any of these 3. So let us start. The part number 4 I am taking directly. So places, this is an important question and application based question. Places A and B, we have 2 places are 100 km apart. The distance between A and B is 100 km on a highway. One car starts from A and another from B at the same time. Means suppose in the morning 9 a.m. sharp, one car starts from A and one car starts from B. Now conditions are if the cars travels in the same direction. Means A starts towards, suppose for example east, then B is also starting towards east direction, same direction at different speeds. Now speed is not the condition for this particular question. Speed may vary as per the condition of the vehicle. So they are running with the different speeds. They meet in 5 hours. So for example, I tell you here this for example we have this A point here and then B point here, and the distance between them is 100 km. Okay, this is 100 km from here. Now this car A starts in this direction, and at the same time from here car this B also starts in this direction with different speeds. Then they both the cars, for example, meet somewhere here. So this car and this car both meets here, means they are parallel to each other in 5 hours. Definitely now you can conclude from here that the speed of the car A will be more than speed of B. That this B car was running slower at the slower speed, so that's why this A is overtaking at this point. I hope it is clear. Now second question, if they travel towards each other. Second condition is suppose car A is here and the car B is here, and the distance between them is again that is constant only 100 km. Now this car starts towards this direction, opposite direction now, and this car also starts towards B and B starts towards A. So they meet in 1 hour. Suppose for example they meet somewhere here. So the time they are taking 1 hour. That you need to understand. What are the speeds of the two cars? That we need to explain, that we need to find out over here. That is what will be the speed of the both the cars. So now we proceed towards the solution of this question. So let the speed of first and second car is x kilometer. Let the speed of the first car, that is A, at point A is x kilometer per hour, and at B the car having speed y kilometer per hour respectively. Okay, now respective speed of both cars when they travel in the same direction equals to x minus y kilometer per hour, and respective speed of both the cars when they travel in opposite directions equals to x plus y kilometer per hour. Now, very interesting thing you will learn over here. What is that? Now you might have traveled in buses or trains. So do you remember when suppose for example I'm putting this two lines. So first bus is running with the speed suppose 50 kilometer per hour, and another bus is running with the speed 60 kilometer per hour. When they overtake, the passengers sitting inside both the buses will feel at some point like they are running at very slower speed. That means suppose their speed is also 50, if the speed of this bus is also 50 and this is also 50, then they will be running parallel, and the passenger inside, they will feel like these two buses are standing, not moving. Clear? While as you might have observed, suppose for example you are riding a bike, and another fellow, you are riding a bike almost 30 kilometer, for example 30 kilometer per hour, and somebody is coming from opposite direction, is running with the 50 kilometer per hour. Then suddenly you feel like a stunning speed you feel between these two vehicles, because at the time when the vehicles cross each other, at that time the relative velocity, and means what, that these two velocities are added, and you feel like your bike is running with 80 kilometer per hour, in this case opposite direction, while as if you are moving in the same direction, these two will be subtracted, means this you will have a difference like feeling. That means 50 minus 50, as I told you, if the speed is same, you will feel like your buses are standing at station, not moving. So 50 minus 50 is equal to 0 speed. And if they are also moving with the little difference, suppose 55 kilometer, then you will feel very slowly that another bus is. So that's why when the buses are moving in the same directions, the respective speed will be subtracted x minus y in the same direction, and while the vehicles are moving in the opposite directions, the speed is added. Okay, so this is what a very interesting thing you must learn. Otherwise this question is very difficult for you to understand. Now speed equals to distance upon time. This is general formula. Though then speed into time, cross multiplication over here, that is upon 1, speed into time equals to distance. So why did we do this thing? Because the distance is constant each time. So we have converted this formula in the form of distance only. So then according to the question, we'll move upside. What is according to the question? I explain you. 5. This is the time. 5 hours. They meet. If the cars travels in the same direction means the respective speed will be x minus y. This is speed x minus y, and the time equals to 5 hour, and distance is equal to 100 kilometer. Okay, so this is equal to, dividing this 100 by 5, 20, equation number first. And the second one, in second case, when the cars are moving opposite direction, in opposite directions, so this speed x plus y and the time they take to meet each other is 1 hour, so multiplying 1 time into speed equals to distance, same only, 100. So this is equal to x plus y is equal to 100. Equation number 2. We can apply elimination method, so we can add also, we can subtract also. If we concentrate on y variables, then we should add. So what we are going to do here, directly adding 1 and 2 we get. Adding 1 and 2 means what? Minus y cancel, 2x. 2x is equal to 100 plus 20, 120. So x is equal to this 120 by 2 is equal to 60 kilometer per hour. So that is speed of the first car. Now we will put the value of x anywhere in 1 and 2. So this value we are putting in 1. So we get x is equal to 60. So 60 minus 20 is equal to y. That is y is equal to 40 kilometer per hour. That is the speed of the second car. Hence, the speed of the first car is 60 km per hour and the speed of the second car is 40 km per hour. Next question, part number 5. The area of rectangle gets reduced by 9 square units if its length is reduced by 5 units and breadth is increased by 3 units. So the first statement, from here we will get first equation, and then second we will get, if we increase the length by 3 units and the breadth by 2 units, the area increases by 67 square units, area of rectangle. Find the dimensions of the rectangle. Dimensions means the length and the breadth. The value of length and breadth we have to give in numerical value. So let us go for the solution. First thing, we need to suppose that let the length and breadth of the rectangle are x and y respectively. Then area of rectangle, that is length into breadth equals to, here we have length is x and breadth we have supposed y, so area will be x into y square units. Now as per the question, we'll move according to the question. Now as question says, the area of rectangle gets reduced by 9 square unit, means x, y minus 9. When its length is reduced by 5 unit, that means x minus 5, and the breadth is increased by 3 units, so that means y plus 3. So here we have length is reduced by 5 units, so x minus 5, and breadth is increased by 3 units, so this thing is 3, y plus 3, as length is increased by 3 units. Then area of rectangle gets reduced by 9 square units, so that is xy minus 9. This is, now as we can do this little calculation over here, that is this x into y, xy, and then plus 3x, then minus 5y, then minus 15 is equal to xy minus 9. So this xy and this xy cancelled, so we have 3x minus 5y, and this 9 will come to this side, so this minus 15 plus 9 is equal to minus 6. So this is our equation number 1. Now also next equation, if we increase the length by 3 units, now instead of this x minus 5 we will have x plus 3, and the breadth by 2 units. So that means if we increase the length by 3 units and breadth, both we have to increase. So that means breadth is also we should increase by 2 units. So y plus 2, x plus 3 and y plus 2 length into breadth. Then area increases by 67 square units. That means xy plus 67. So here it is, x plus 3 is the length and the breadth is y plus 2. So length into breadth, that is area, and the old area, that is xy, will be increased by 67 units. Again, like above relation, this xy cancelled, so 3x, this 2x plus 3y, and then plus 6, and then minus 67, so is equal to minus 61. This one, this is actually plus 67, this will go to that side, so minus 67, and 3 to the 6, so plus 6 is equal to minus 61 is equal to 0. Equation number 2. Now by cross multiplication, we are applying cross multiplication method to solve these two. So for that, x upon, directly I am writing here this x upon, now direct multiplication of this thing, minus 5 into minus 61 is equal to minus into minus plus 61 into 5, 305, and then this way from here to here, then minus extra from downwards to upward, so minus into minus plus, and 6 3s are 18, so both are positive. Next is equals to minus y, this is a, now we are talking about middle term, so minus y upon this minus y, now 3 into minus 61 is equal to minus 183. Now these two will be multiplied, so for that minus into minus plus, and 6 2s are 12. The last one is constant 1 upon, that means we will be leaving this thing, so 3 3s are 9 here, and this minus and then extra minus will come from down to upward, so minus into minus plus, and 2 5 are 10, implies x upon 18 plus 5, 323. Next is minus y upon minus 171 minus 183 plus 12, and then is equal to 1 upon 19. Now same thing, first we will take this x upon 323 and 1 upon 19, and then we will take minus y upon minus 171 and 1 upon 19. Then we will have two relations. So what is that? First is this one, so this is equal to x upon 323 equals to 1 upon 19. This implies x is equal to 323 will go there, 323 upon 19, 19 will be 19, and then 12, 13 will be here carry, so 133, 19 7 ja 133, so 17, x is equal to 17, and then we will take these two, so in this case what will happen, this minus 100, minus and minus cancel, and plus 171 will go here, so 171 upon 19. So 19 9 ja 1. Y is equal to 9. Hence, length of rectangle is 17. Length of rectangle is 17. Here breadth is 9 units. So this we was asked in the question that find the dimensions. So these are the dimensions, length and breadth.